This is a worksheet on pH. So the beginning of it is talking about some just basic concepts reviewing on how to do pH problems or interpret pH problems. At the top here, I'm just discussing what the pH scale is and what it means. And so if pH is less than 7, it's acidic. If pH is more than 7, it's basic. If pH equals 7, it's neutral. And then I say here, every change in 1 for the pH is a tenfold change in concentration. And what I'm talking about there is if you have something that is 1 away, like 4 and 5, then a 4 is more concentrated in terms of how much acid it has in it, how much H+. And so if it's a 4 in pH, that means it has 10 times as many ions in it as a 5 does. Or if you're 2 away, let's say we're comparing a 4 and a 6, the 4 would have 100 times as many H+s in it as the 6 would. And so something important to understand about the numbers that we're getting out of this. Now down here I'm just going to go through some definitions. pH, P is the operator that means negative log, so pH is just negative log of the concentration of H+. Now when we put H+ in water, it does this funny thing where it sort of just grabs onto the water, and so instead of it being H+ when it's in solution with water, it actually makes this H3O+. And what that is a water with an H+ just sort of attached onto it. And so keeping that in mind, you can interpret it as either one of these, negative log of H+ or negative log of H3O+. They're pretty much the same things. I'll use them back and forth sort of synonymously. So if you're wondering why I use H+ sometimes and H3O+ other times, it's really just because I'm varying the symbols, but they mean exactly the same thing. POH, on the other hand, is talking about hydroxide ions. It's the negative log of the hydroxide ion concentration, or OH- concentrations. The other thing here, we've got a couple rules down below. The most important one of these is this pH plus POH equals 14. This has to do with the ionization of water, the autoionization, where water will split up into H+ and OHs sort of on its own, and there's an equilibrium there. That equilibrium has a value of 10 to the negative 14th. And through some log math, we get that pH plus POH has to add up to be 14. And so we'll utilize that at some point. The last thing we're going to talk about here is some sig fig rules for this. And so sig figs with pH is it's kind of weird because it's a logarithmic scale. If it's a logarithmic scale, that actually means that the numbers out front of the decimal are just placeholders, so we don't count them in the pH. What we're counting is the decimal places after the decimal, or the place values after the decimal. So what we say is that the number of decimal places for a log has to equal the number of sig figs for the original number. And I'll go through some examples of that as I go through this sheet and sort of explain how that works. Okay, so this first set here is just asking us to find the pH of something using the H3O+ concentrations. This is simply just using the definition of pH. So pH, remember, equals the negative log of the concentration of H. And so we're really just plugging these values in. So on A here, we're finding the negative log of 3.16 times 10 to the negative 8. If you plug that into your calculator, you should get something like 7.5, and this is where sig figs come in. So I'm going to write it down 7.500, and that's because this is pretty much what came out of my calculator. There are some digits after that, but it rounds to 7.500. The 7 is not a significant figure in this because pH, as I said, is a log value, and if we're talking about a log value, then anything before the decimal point is just a placeholder value. If you ever want to come in and have me explain the complicated sort of logarithmic algebra that goes into that, I can. But otherwise, it might just be better to remember that anything after the decimal counts, anything before the decimal does not count. So if we have 3 sig figs in our original number, we should have 3 sig figs in the end. We're going to count the 0.500, not count the 7. So this is what we end up with here. Problem B, very similar. You're going to have negative log of 1.29 times 10 to the negative third. Plug that in. you get 2.889. pH on the next one, again, just take the negative log of it. You should get 12.900. And then taking negative log of 1.0 times 10 to the negative 7th, you get 7.00. This one has one less decimal place because the original number had one less sig fig. So that's how that one works. For this problem number 2, we're trying to find the pH, but we're given the hydroxide concentrations. And so that means that we can't just plug it in and find the number directly. It's a two-step problem. So the first thing that we're going to do is we're going to find pOH. pOH, again, equals the negative log of the concentration of OH. And that's what they're giving us, is the concentrations of OH minus here. Okay, then the next thing that you're going to use is this relationship up here that says pH plus pOH equals 14 up there in the top right. So rearranging that a little bit, we get 14 minus pOH equals pH. And that's the second relationship that we're going to use. So as I said, the first thing we do here is we plug it in, and so I get negative log of 2.34 times 10 to the 8th, negative 8th, sorry, equals 7.631. Okay, and so that is our pOH value, and then we need to figure out what the pH is. So we just take 14 minus that, and we get pH equals 6.369. For B, same process. We find the pOH by taking the negative log of the concentration that's given there. We get pOH equals 9.020. And then I find here that the pH would equal 4.980. For C, take it, we get the pOH equal to 0.040, and then pH is going to be 14 minus that, so 13.960. And then the last one, plug it in, negative log of 1.58 times 10 to the negative 13. We get pOH equals 12.801, which means that pH is going to equal 1.199. All right, so that is going from concentration of hydrogen to pH and concentration of hydroxide to pH. All right, going on. So this next one is going the other way. It says how to determine the concentrations here of hydronium if we have pH. And so what we're going to do here is we're going to use kind of the inverse formula of that, and we get concentration of H3O plus is going to equal 10 to the negative pH. And again, I use H3O plus and H plus sort of interchangeably if you're wondering why that is. And so what we have here, if we want to do this example, if we want concentration of H3O plus, that's going to equal 10 to the negative 2.35. Plugging that in, we get 0.0045. All right, and that is the answer there. The unit on this is molar because it's concentration, and so that's what you end up getting out of that. Notice for sig figs here, 2.35 as a pH. The 2 is a placeholder, so we're only counting the 3 and the 5. So we have 2 sig figs there. When we go to talking about concentration, we're doing the normal way of counting sig figs, so 0.0045 is what we end up with. All right, on this bottom one here, it gives us the pH. Again, it asks us to calculate the concentration and to find the pOH. Those are actually two sort of independent processes. A lot of people, when they're seeing this, they find the concentration of H3O plus and they're confused about where the pOH came from. That's a separate process, and I'll kind of talk about that as I do it. So on this first one, we get concentration of H3O plus equals, and then you just do 10 to the negative pH. This one actually ends up just being 10 to the negative 9, and there's no real way that you can simplify that anymore. pH of 9 doesn't really have any sig figs. Neither does 10 to the negative 9. So this is what it ends up being there. In terms of the pOH, as I said, that's kind of a separate problem. What we do is we take into account the fact that pH plus pOH equals 14. And we see, okay, if pH is 9, then we know that pOH is going to equal 5. All right, this next one gives us pH of 4.58. So we're going to say 10 to the negative 4.58. Put that into your calculator. You get 0.000026. Now you could have said 2.6 times 10 to the negative fifth. That would have been acceptable as well. But that's molar. For the concentration here, for the pOH, we're going to take 14 minus 4.58. And you get pOH equals 9.42. All right, for this last one here, we say 10 to the negative 2.14. We get concentration there equal to 0.0072 molar. All right, and then pOH on this last one equals 11.86. Okay, that is that on this first page. You can go ahead and flip it over to the back. So this is a slightly different process, but it's not too bad either. What's happening here is we're putting in actual chemical acids and bases, and so rather than just saying the concentration of H3O is this, or the concentration of OH is this, what we're doing here is giving you some actual acid or acidic or basic substances, and we're having you figure out how this works. And so what's happening here is this first one here is an acid. You can tell because it has an H out front. The second one is a base because it has an OH there at the end. Third one, an acid, it has an H out front. Fourth one, a base because it has an OH in the end. And so what we're saying here, and it says assume that we're just giving off one of these hydrogens for number 1. And so what we're saying here is if we have 0.058 molar of this acid, we're going to have 0.058 as our concentration of H3O plus. Because this acid is going to take those H's that are on the front and put it into solution. And so because we have an acid here and it tells us the concentration of the acid and we're going to assume it's a strong acid, we end up with 0.058 for the concentration of H3O plus as well. And then we just know pH equals the negative log of the concentration of H. So negative log of 0.058. Plug that in and you get 1.24. Just 1.24 as your pH. On the second one, this is kind of a two-step problem because they gave us OH. All right, so that means we've got the concentration of OH minus, all right, this is a base that they've given us, equals 0.090 molar. All right, if we're going to do that, then we're going to find pOH because we have OH right now. That's going to equal the negative log of 0.090. All right, plug that in. You get 1.05. All right, and so that's our pH, but we want that's our pOH, but we want pH. So we take 14 minus that, and we get pH equals 12.95. For number 3, this is just giving us an acid here again. So we know concentration of H3O plus equals 0.25 molar. All right, so we're going to plug that in then. pH is going to equal the negative log of 0.25, which equals 0.60. So very, very low pH, very acidic in this case. And then for the bottom one here, it's given us a base again, OH, so we say concentration of OH minus equals 0.45 molar. So since we've got OH here, we'll find POH first. POH equals negative log of 0.45. Plug that in, you end up with a 0.35 for your POH. Okay, and then pH is going to equal 14 minus that, so pH equals 13.65. Okay, so this table here at the bottom actually, it looks sort of intimidating, but it's not too hard. What we're doing is we're just filling in the blanks. Some things to think about, pH and POH always add together to be 14. So in the case of, number 1's already done for you. In the case of number 2, they give you a pH equal to 3. So we know that pH in that case is 11. For concentration of H+, it's always 10 to the negative pH. So we write 1 times 10 to the negative third. So this 3 that is in the second column comes up as the exponent is negative pH there in the first column. And so you should see the 3 repeated here and here. And then this one is going to be 1 times 10 to the negative 11 molar. And again, we see the molar here. We see the 11 here and here. And that happens all the way down the column. So whatever your POH is, it always ends up being the exponent in the third column. Whatever the pH is, that ends up being the exponent in the first column. So this next one, it has a concentration of OH. It's got a negative 7 there, so that means POH is 7. Okay, this POH is 7. pH and POH have to add together to be 14, so pH is also 7. Which means this is 1 times 10 to the negative 7 molar as well. For number 4, we've got negative 9 there, so that means the pH is 9, which means the POH is 5, which means this is 1 times 10 to the negative 5 molar. All right, column number 5 here, we've got POH is 1, that means pH is going to be 13, 1 times 10 to the negative 1 for the concentration of OH, 1 times 10 to the negative 13 for the concentration of H+. All right, number 6, we're given pH here. That means POH is 13 because they have to add together to be 14. Concentration 1 times 10 to the negative 1 molar for the H+. For the OH minus, it's 1 times 10 to the negative 13 molar. Going here to row 7, we get 3 here for the POH because it has an exponent there of negative 3. If POH is 3, then that means pH is 11, which means this is 1 times 10 to the negative 11th molar. Row 8, we've got 1 times 10 to the negative 6 for the concentration of H. That means our pH is going to be 6, which means our POH is going to be 8, so that we get 14, which means this is going to be 1 times 10 to the negative 8 molar. For number 9, we're given 12 for the POH. That means the pH is 2, which means this is 1 times 10 squared. I'm sorry, to the negative 2 molar. And this one here is 1 times 10 to the negative 12 molar. Wrote 10 here at the bottom. pH is 4. That means POH is 10. 1 times 10 to the negative 4th. And then here we get 1 times 10 to the negative 10th. All right, and then going through here, the last thing here that it asks us is it an acid, a base, or neutral? The way that we can do this is if you just look at the pH column, remember if pH is less than 7, then it's an acid. If pH is more than 7, if it's a base. If pH is equal to 7, it's neutral. So that first one is a base. The second one, pH 3, is an acid. Third one, pH 7, is neutral. Notice also when it's neutral that things look pretty much the same for the H plus and the OH minus, and so that's why it ends up being neutral there. For number 4, pH is 9, which makes it a base. For number 5, pH is 13, that's definitely a base too. For number 6, pH is 1, that's an acid. For number 7 here, pH is 11, that's a base. For number 8, pH is 6, that's an acid. pH of 2 is an acid. pH of 4 is an acid. All right, so that's how that works. If you have any questions on this worksheet at all, make sure that you come in and talk to me about it. Otherwise, make sure you're reviewing things for the test.